Hi, welcome back to Alien Space Education. My name's Andy, the host of this amazing podcast you're listening to. Please don't forget to like, share, and talk about it. Leave comments or everything like that. Today's episode is about the last major big planet in our solar system, also known as the last planet in our solar system, Neptune. Now, this is going from Mercury to Neptune as classified as the main planets of the solar system. Dwarf planets, we're doing dwarf planets next, and we'll cover other planets, so please don't worry. And then we get onto more other things within the universe that I really hope you like and enjoy. So let's get into looking at Neptune. It's one of the most fascinating and enigmatic worlds in our celestial neighborhood. Okay, we're looking at its atmospheric dynamics, the ring system, and its intriguing moons, and we explore its history. Now, Neptune was one of the most interesting ones we discovered using mathematics. So let's get into it. Neptune, the basics, the very, very basics, the fun parts. Neptune is the 8th planet and furthest planet from the Sun, orbiting at an average distance around 4.5 billion kilometers or 2.8 billion miles, which is around 30 astronomical units. Now, an astronomical unit, remember, is the distance from the Sun to the Earth. So we're 30 times the distance from the Sun to the Earth. It takes Neptune around 165 Earth years to complete one orbit around the Sun, giving it the longest orbital period of any planet in our solar system. Now, this is the main planet. Remember, we're not talking dwarf planets. Okay. In terms of size, Neptune is the third largest planet by diameter, so it's bigger than Uranus, measuring about 49,244 kilometers or roughly 30,598 miles. It's big. It's smaller than Uranus. I thought it was slightly larger, my apologies, but still a giant in its own right. Neptune has a mass of about 17 times that of Earth, makes it one of the more massive planets in our solar system. These are the gas giants, so Jupiter, Saturn, Uranus, and Neptune. They're all a lot bigger than Earth because of the gassy atmosphere and the gas consistency they have, which is what's making them so big. All the other planets, the other planets, Mercury, Venus, Earth, and Mars, are rock planets. Neptune is classified as an ice giant along with Uranus. Its classification reflects its composition, which is different from the gas giant Jupiter and Saturn. Neptune's atmosphere are primarily made of hydrogen and helium, same as Uranus, with significant amounts of water, ammonia, and methane. The presence of the methane is responsible for Neptune's striking blue color as it absorbs red light and reflects blue and green wavelengths. So, just like Uranus, it does have that blue glow. A Neptune day, or its rotational period, so like us, it takes 24 hours. For Neptune, it's about 16 hours long, and its actual tilt is about 28 degrees. That's slightly less than us, so it's still very similar to the Earth's tilt. Tilt is caused seasonal variations on the planet, although they are less extreme than those on Uranus. Now, if you listen to the last podcast, you'd have read that Uranus is on its side, so it has extreme fluctuations in weather and 900-mile-an-hour winds. Neptune doesn't. So, what do we know about Neptune's atmosphere and weather? Neptune's atmosphere is one of the most dynamic and intriguing aspects of its planet. It's composed primarily of hydrogen, about 80%, 19% helium, with traces amounts of methane, water, and ammonia. Methane is the key of Neptune's vivid blue color, which makes it stand out among the planets. Almost the atmosphere of Neptune is characterized by strong winds and storm systems. Neptune has some of the fastest winds in the solar system, speeds that reach up to 2,100 kilometers per hour. Remember, Uranus was 900. This is faster. So it is a big difference. That's about 1,300 miles per hour. So 2,100 kilometers to 1,300 miles an hour. These high-spin winds contribute to the planet's complex and active, very active weather system. One of the most notable features of Neptune's weather is the presence of a storm system. Just like Jupiter has a red spot storm system, Neptune has something similar. The planet has been observed to have a large dark storm, similar to Jupiter's red spot, but with a blue hue. The most famous storm in Neptune is the Great Dark Spot, which was discovered by Voyager 2 spacecraft during its flyby in 1989. This storm was a massive anticyclone, but has since been observed to have changed and faded over time. It doesn't mean it's gone. We don't know if it's still there or not. We'll have to keep looking at it and watching it and monitoring it. Remember, it is spinning and it is going around, so we have to keep a very close eye on it and make sure we're monitoring it at the right time. Neptune's atmosphere also features clouds of methane gas. These clouds are formed in the planet's upper atmosphere and are responsible for some of the planet's distinctive features, including bright and high altitude clouds that contrast with the dark regions of the atmosphere. So just like when we're looking up at the sky, we see blue, but the clouds come over, so it looks bright, sometimes it looks dark. Well, and Uranus, we're looking at the other side, we're looking down, so we can't see through it. So the clouds make it nice and light and bright because they're so high up, and we can't see the dark interior. Neptune also has a significant internal heat source, which contributes to dynamic weather. Despite its a great distance from the Sun, Neptune emits more heat than it receives, indicating that the planet has a substantial internal heat reservoir. This internal heat likely plays a role in driving the planet's atmosphere and dynamic weather patterns. So it's really, really hot inside, but the clouds are there and they're forming. So something is controlling all this. And just like we've learned about the Earth's systems and Venus's, Mars, we're learning about outside planets. And Neptune is a gas giant. So to have an internal heat source that's producing this, it's hotter, it's producing more heat than it's giving out, makes it really, really unusual. And we're not sure why that's happening. So we have to keep looking at it. It's really, really cool. Neptune also has rings. Neptune has a system of rings. Although they are very much fainter and less prominent than those of Saturn, the rings of Neptune were discovered by Voyager 2 spacecraft again, during its flyby in 1989. The rings are composed of dark, icy particles and are named after an astronomer who made a significant contribution to the study of Neptune. So let's go through the rings. They're, as like Saturn's, Jupiter's, they're divided into different sections. So we've got the Adam's ring. This is the brightest of Neptune's rings, and it's located closest to the planet. It is named after the astronomer John Crouch Adams, who played a key role in the discovery of Neptune. The Adam's ring is relatively narrow and contains high concentrations of particles compared to the other rings. So the brightest is the closest, and it's the Adam's ring. The Leverrier ring is located further out. It's located further out from the planet. It's named after Urbain Leverrier, who independently predicted the existence of Neptune. The Leverrier ring is fainter than the Adam's ring and is composed of dark ice crystals. The Gali ring is one of the fainter rings and is named after John Grotfield Gali, who was the first to observe Neptune. The Galilee ring is located further from Neptune and is less reflective compared to the other rings. In addition, the main rings, Neptune has several faint ring arcs, which are clumps of particles within the rings that create localized regions of high density. These arcs, although they are thought to be results of gravitational interactions with Neptune's moons. Now, what that's saying is the main rings we've seen, the three rings, we can see them. These other rings, they're very faint and they're like arcs. So they're like a semicircle going round, so they're pulled by the moons. But they do have a trail that always links them up. So they are a ring, but they gather in one place, so it looks a little bit thicker. The rings of Neptune are relatively young and are believed to be maintained by interactions of the planet's moons, and some of Neptune's moons act as shepherd moons, helping them confine the rings' particulates within certain regions and prevent them from spreading out. So even though they're clumping together and being close to the moon isn't letting them drift away, it's holding them in place. The moons themselves are very diverse. Neptune has a complex and diverse system of moons, with 14 known satellites. The largest moons, the ones we're going to cover, there's quite a few of them, so bear with me. We have Triton. Triton is the largest moon of Neptune, one of the most intriguing moons in the solar system. It has a diameter of about 2,710 kilometers, or approximately 1,680 miles, making it larger than Pluto. Triton is unique because it has a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This suggests Triton may have been captured by Neptune's gravity rather than forming alongside the planet. So Triton could be a giant asteroid or comet that's been pulled into orbit, but it goes the opposite direction. It's really, really weird, but it's really, really cool. Triton is also known for its geological activity. The moon has a surface covered with ice and features cryovolcanoes, ice volcanoes, that have erupted with a mixture of water, ammonia, and methane. These eruptions create plumes that can reach high altitudes and contribute to Triton's thin atmosphere. The moon's surface also shows signs of seasonal changes, with bright reflective regions and darker and more cratered areas. So think of our moon. We have craters all on one side, and then we have dark patches where it's all okay. But then there's volcanoes, ice volcanoes going off. Wow, that's a lot of different things. So Triton is really, really weird, really alien. Could be from outside our solar system, could be from within our solar system. We don't know, but the fact it's going in the opposite direction really makes it strange. The next moon is Proteus. Proteus is one of Neptune's larger moons, has diameter of about 420 kilometers or 260 miles. It's an irregular shaped moon with a heavily cratered surface. Proteus is thought to be composed of ice and rock, so it may get smaller if it's made of a lot of ice. Nereid is one of Neptune's smallest moons and has a highly elliptical orbit. Its diameter is about 340 kilometers or 210 miles. It is thought to compose of ice and rocks. Nereid's orbit and composition makes it interesting target for future studies. So even though it's smaller, the fact that it's highly elliptical means that it's going a lot slower because it's got further to travel. So it's one to worth watching and makes it easier to land on. Larissa is a small moon with a diameter of about 200 kilometers or 120 miles and has relatively irregular shape and is believed to compose, again, of ice and rock. Because these moons are so far away, water can't obviously be liquid, it has to freeze. But the fact they're on rocks as well, where's this water coming from? How's it getting there? Where has it come from? Is it from Earth, or is it a different type of water? Is it salt water, or is it fresh water? We don't know. We just know it's ice water. So it's these things we do have to consider. Neptune's moons provide valuable insight into the formation and evolution of the planet's satellite system. The diverse characteristics of these moons, from Triton's geological activity to its irregular shapes of the smaller moons, offer clues about the history and the dynamics of Neptune's moon's system. So there's still lots to learn, and we still have to keep studying to find out. Neptune has been visited by only one spacecraft, Voyager 2, which conducted a flyby of the planet in August 1989. Voyager 2 mission provided the first and only close-up images of Neptune's moons, revealing much more about the planet's atmosphere, rings, and satellite systems. During its flyby, Voyager 2 discovered Neptune's rings and provided detailed observation of the planet's storm system and weather patterns. The spacecraft captured the first close-up images of Neptune's Great Dark Spot and Titan's geysers. Remember, the geysers are ice, significantly advancing our understanding of the planet. Since Voyager 2's flyby, no spacecraft has visited Neptune, but the data collected by Voyager 2 continues to be analysed today. Further exploration of Neptune could involve sending a dedicated mission to study the planet's atmospheres, the ring, the moons in greater detail. Proposed missions concepts include an orbiter to study Neptune's atmosphere and ring system, as well as a lander or a probe to explore Triton and the other moons. The exploration of Neptune remains a priority for future space missions, and scientists continue to study data from Voyager 2 to learn more about its distance and dynamic planet. Advances in space technology and missions planning will hopefully lead to new discoveries and greater understanding of Neptune and its place in the solar system. So even though it is discovered by maths, even though Voyager 2 went past and only took a few glances of it and did as much study as it could before it drifted away, there is still a lot to learn, and the only way we're going to learn more is James Webb Telescope having a look at it and try and get more better, seeing what images it can get, but also the fact that we do have to send more spacecraft out there. As we wrap up this exploration of Neptune, it's clear this giant blue planet is a remarkable beauty and complex. From its powerful winds and dynamic weather to its intriguing moons and faint rings, Neptune continues to captivate the imagination of astronomers and space enthusiasts alike. The reason we, amateurs like myself, use telescopes is because it is, if we can see it, it is beautiful, but it is very, very hard to see, and we have to get the alignment just right. Smallest degree out is a long, long way in space. So, but it's a real challenge to try and see it. But when we see it, wow, it's amazing. I really hope any amateur astronomers are listening and can share some pictures. Get in touch. We'd love to see them. The study of Neptune not only enhances our understanding of the outer solar system, but also provides valuable insight into the formation and evolution of our planetary system. As we look forward to future missions and discovery, Neptune remains a key object of interest in our quest to unravel the mysteries of the cosmos. Thank you again for joining me in this episode of Alien Space Education. I really hope you're enjoying our journey through this blue giant and the solar system so far. To be sure to subscribe, rate, leave a review. In our next episode, we'll take a closer look at the fascinating worlds of exoplanets. Well, actually, we're not. We're going to look at dwarf planets, and then we're going to go on to exoplanets. I'm going through a process. We'll get there. What we've learned from discovering the planets beyond our solar system until then, stay curious and remember the universe is full of wonders waiting to be explored. My name is Andy, and this has been Space for Alien Space Education. Thank you.